our next guest is here to decipher the big mess behind Bitcoin Ordinals. He wrote his first program when he was only 5 years old, but his entrepreneurial nature led him to co-found a couple of startups, a couple of successful startups. It is said that you can tell if somebody has what it takes to be an entrepreneur by the way he complies to rules. And our next guest likes to write his own rules in code. So, without further ado, you saw him in the first panel of the day about investment funds and trends for 2024. Now let's welcome him again on the stage, Daniel Luca from EdenBlock.
Okay, hello. So I'm here to talk about Bitcoin Ordinals. I'm kind of interested to know who holds any kind of NFTs. It could be on Ethereum, Solana, whatever, okay? And then who holds ordinals or runes? Okay, a lot more people than I expected. So there are a few things that I didn't know about Bitcoin Ordinals, and I set out to learn more. And this is what we're going to go through. So first of all, I want to make sure that we understand the difference between ETH, SOL, or contract-based NFTs, and Bitcoin NFTs, which are UTXOs. Next, we're going to understand what ordinals are and what inscriptions are. And then we're going to dive into the giant mess. Most of my talks are technical. So we are going to go into a few technical things, but I think it's very important to understand the rules that govern the universe in order to understand how this works. So once we go through that, we're going to be able to think for ourselves. So who am I? I'm Daniel Luca. I'm a tech VC at EdenBlock. My experience has been through, started in 2017 in blockchain full-time. I was part of Consensys, built an analytics platform. I went to Consensys Diligence, where I did a lot of security. That's why I like to dive into the details. I co-founded a stablecoin after that. And now I'm with EdenBlock, which is a crypto VC. So first of all, smart contract NFTs. They are the norm. This is where the NFTs were actually invented. This is account-based ownership. So that means that you have something like a smart contract that defines how things work. You don't necessarily have to read all of this. It's just like to understand that there's code governing what happens. You have code that tells you who the owner of an NFT is, what's the balance of a specific person. And you have methods that allow you to transfer NFTs and do all kinds of stuff. It basically, Okay, it basically looks like this, which is, you can kind of think of this smart contract has this state, and for token ID 1, it knows that account 0xD07 owns it. This is how it kind of works in the smart contract world. And then you have Bitcoin non-fungibles, or the same NFTs, and they are UTXO-based. This is a very different architecture for the blockchain, but this is the original architecture, and this works very, very well for Bitcoin. And these are non-Turing smart contracts. Like, you do have smart contracts on Bitcoin, but you can't do everything with them. So you are limited by the amount of operations that exist within, and that's why people kind of invented these ways to create ordinals. And then we're going to understand ordinals and inscriptions. So UTXOs, or I'm going to give you some examples, is like how this actually works. When you have a transaction, you have an input and an output. So that input is attached to a wallet, and that means like my wallet has 1 Bitcoin, and I want to send that Bitcoin to someone else. So I create a transaction that has an input, which identifies my wallet, and has an output which identifies the destination, and I send that Bitcoin. Things get a little bit more complicated because you actually have to spend all of your Bitcoin whenever you create a transaction. So that means if I want to send 1.2 Bitcoin, and I have 2 wallets with 1 Bitcoin each, I have to spend all of the input, like spend 1 Bitcoin from one, spend the other Bitcoin from the other one, take 1 Bitcoin from one, take 0.2 from the other one, combine them into 1.2, which is what I want to achieve, but then the rest, I will send it to another wallet of mine. I can't leave that output unspent. That's why we have the UTXOs. Okay. So that was like maybe the most weirdest part about UTXOs. And now I want to go into ordinals. And ordinals are actually a numbering scheme for Satoshis. 1 Satoshi is the smallest amount of Bitcoin that can exist. And that means that if you look at 1 Bitcoin, let's say that this is 1 Bitcoin, and 1 Bitcoin has 100 million Satoshis. The ordinal identifies 1 specific Satoshi, and it says, oh, this is sat number 1, or this is sat number 4. So it kind of creates this difference between individual Satoshis. Ordinals is just the numbering system for these Satoshis. And then inscriptions. The inscriptions are just arbitrary content attached to an ordinal. So that means I can write something to that Satoshi, and that then becomes this NFT. Those are the ordinals plus inscriptions. So that means that, for example, I could write something with this code. I could write NFT Bucharest 2024 to Satoshi number 1 in that block. This is basically how it works. Okay. If I want to do that, I'm going to split that Satoshi into 1 output. I attach that code that says, oh, this is NFT, this is content with NFT Bucharest 2024 attached to that Satoshi, and the other 99999 Satoshis don't do anything. They don't have any data attached to them. So once we understand all of this, we can go into the mess that exists within for ordinals. So first of all is dust. Dust is the smallest amount of Bitcoin that can be sent in a transaction output, which is still considered economically sensible to spend. And I can explain that in a different way. Let's say that we have 1 Bitcoin, and this one has 100 million Satoshis. And if you imagine a bucket of water, it's like taking each drop of water and kind of packaging it into something. It's less effective to do that because I could just have 1 bucket of water, or I have 100 million cups having each drop. And Bitcoin protects itself from creating this problem because it says there is a limit, minimal limit for a group of Satoshis, and that has to be like at least 546 for 1 specific type of transaction. And it's going to get a bit more confusing from this part, because it's 546 for 1 specific type of output, but it's 294 for a different one, 330 for a different one, and for multisigs, it kind of varies, but it's higher. So what people do when they create these ordinals is that they get a group of 600 Satoshis, and they say, oh, this is going to be the group of sats that host that ordinal and host that inscription. But they're only going to write that information to one of the sats. So you have one sat which actually has the information, and the other 599 that don't really do anything. They're just there to have something, to not be considered dust on Bitcoin. And this creates problems because it makes every transaction a bit more difficult. This is Casey. This is the guy who created ordinals, and this is the guy who created runes. And there's no specific standard that he crystallized. He started saying like, oh, I have this idea to create this. He created the initial presentation, and then he changed things over time. And right now, he's one of the, he's kind of the Jesus of ordinals, of Jesus of runes. Okay, so when you save this information on Bitcoin, you have these operations, and we can go into them to understand them a little bit better. I translated the code. The code to the left is the actual Bitcoin operations, and the code to the right, it translated to, if false, then add the text ord, add the metadata. This is just saying that this is text, and the next part is, this is NFT Bucharest. This is the text that I want to save. And instead of text, it could be an image. But the thing is, Bitcoin has to ignore this data. Bitcoin has to ignore these operations because the first line says, if false. So it doesn't really happen. So the problem is that Bitcoin ignores all of this, but in order to have this mean something, you have to use Casey's software. And Casey's software looks at all the transactions and says, oh, this is the actual information I have to look at, and this is what an ordinal is, and now I see this existing, and I give it one number, and explorers can look at it. But Bitcoin doesn't really do anything with it. It has to ignore it. It's designed like that. So, and there's one single implementation for this, which Casey created. Which is basically like, run my software or, no ordinals for you. This is, I think, a big problem because everything is centralized towards one implementation and towards one person who is creating that implementation. And he's changing the software and how things work all the time. So people are obliged to update even if they don't like the idea. Another problem is the size. The thing is, all of the data is saved on chain. And with each operation, you can add at most 520 bytes. The image that I added here, like it's this really, really small image, is actually larger than 520. It's 525. But I just wanted to tell you like how small of an information is this. And this also creates more complexity when you have to create ordinals. Yeah. This is the zoomed-in image. Just to know, this is a mutant hound inscription. Another problem is now you have social consensus over Bitcoin or code consensus. With Ethereum, with Solana, you have a smart contract that tells you who owns what exists on the chain, and you look at it. But because Bitcoin ignores all of that, you need all of the people who create explorers, who look at ordinals and who care about ordinals, to all agree that that is the truth. The network doesn't tell you what the truth is. The data exists there, but you're going to have differences if you want to create your own implementation. So still, we have Casey who decides what the reality is. So another problem is with the versioning system. And if you look closely at the version, you're going to notice that there is no versioning system. And this is a big problem because he keeps updating, and you can't even stop to a specific version. There's nothing defined there. This creates a lot of problems, especially for developers. You don't know exactly where to stop. You don't know what version you're on. You don't know your ordinal, what type it is. You just have to use Casey's software as gospel, saying that this newest version is the reality right now. And if he creates a new one, that's going to be the reality. Another big problem is that there are no real smart contracts that control the market. Whenever you buy one ordinal, you have to send Bitcoin to some address, But there's no smart contract that gives you the ordinal back. You have to wait for the people who receive your Bitcoin to send you the ordinal like at a later date. So you have to trust them. There is no code and never has been. And there's, again, a lot of trust, not in the system, but in the people running these collections. So you're left with this problem right now. Like, you have Ethereum, you have Solana, and you have other networks which have these like lots and lots of features. Everything works well. They're so solid, and you don't have to trust anyone because you can look at the code and say like, yeah, I know if I buy this, if I mint this coin, I will get something back. I see it. I see it in the code. I don't have to trust anyone. But Bitcoin has to level up. Right now, they're just kind of trying to fight bosses. And they don't have the right level. They don't have the right equipment. They don't have the right skills. But I am hopeful that this will change in the future. I do have to say that even though I kind of trash-talked ordinals a lot, we at EdenBlock invested in ordinals projects. I myself hold ordinals, and I still like them. I just want them to do better. And I think this can happen in the future, but at first, you have to identify the problems before you solve them. Okay, so this was my talk. I'm not sure if there are any questions. You can find the talk online. You can follow me on Twitter or on X. If there are any questions, shoot. If not, thank you.